Hello everyone, welcome back to Cambridge Guru once again. As you know that we are doing our AP Calculus series in which we have already done 3 topics, 3 lessons basically we have done. And the last lesson, in the last lesson we did even and odd functions, and majorly we covered the topic transformations of functions, and we also did a couple of examples. So let us continue with that, and today we are going to start with a new topic, which is the polynomial functions, right? So let us start. So we have what is called as the polynomial functions. So as you know that we have already covered the definition of a function. So basically we are doing the types of functions, right? Even on the functions we have done, then we deal with transformation of functions. So we will first start with understanding what do you mean by polynomial expression, right? So I would say that any expression, any algebraic expression, algebraic expression in the sense that which involves variables and constants. And what kind of variable there will be? There are polynomials which involves more than one variable, but here we are only dealing with the functions or calculus, whatever is in our syllabus, that only deals with a single variable. Single variable meaning there is only a single independent variable, right, which is x normally. So we are doing polynomial function in a single variable x, and polynomial or algebraic expression since we are defining polynomial. So any algebraic expression which consists of a single variable. Okay, so any algebraic expression of the type what type is which is a x raised to power n plus, I would say it is a, let us say 0, then a1 x raised to power n minus 1, then a2 x raised to power n minus 2, and so on, and last term of this expression is, let us say, just a with the coefficient n. Okay, so any algebraic expression of the type this, where we need to define what is a and x. X is normally variable, where I would say that a0, a1, a2 till an. Now what are these? These are the coefficients of the variable, coefficients of the variable x, right? And this n is a whole number or a positive integer. In other sense, you can also write this as it is also a positive integer including 0. We won't say that 0 is a positive or a negative number. So a positive integer will start from 1 plus 0 also. So n can have a value. Can n have a value 0? That we'll find out. Okay, so yes, it can have a value 0, but not in this case. a1 x raised to power, if your expression is starting from n minus 1, then it cannot be 0. Then it would, right? Why I'm saying that it cannot be 0, we will see with some examples, right? So n is a whole number. I would say that not n, but n, you would say that the exponent, where the exponents n minus 1, n minus 2, all these must be whole number. Okay, that would be correct, because if I take the value of n as 0, right, then you will get some value a1 x raised to power 0 minus 1, which is a1 upon x. that will be called an algebraic expression, but that won't be called as a polynomial. So here we have a condition for defining any polynomial function to be an algebraic expression is that the exponent of the variable must be a whole number. Must be a whole number. Okay, and I should omit this, right? So this will be the correct, I would say, the definition, that exponent of the variable must be a whole number. So if this is your expression and you are including 3 and 4 terms, so n has to be, let us say you are including expression till a to x raised to power n minus 2, then this exponent should be greater than 1. Okay, it can be 2, right? Because if it is 2, then you will get a naught x square plus a1 x raised to power 1 plus a2 x raised to power 0, and this is allowed. Okay, had it been just n equal to 1 or n equal to 0, then you will get x raised to power minus here, right, and minus 2 here. If n is 0, then that will be in the denominator, and the exponent will not be, in that case, a whole number or a positive integer. Okay, so exponent of the variable must be a whole number, I would say, of each and every variable, not just a single variable. Okay, so for example, if you say that which of the following example, which of the following can be defined or considered, as polynomial functions or expressions, right? So let us say a part is x square plus x plus 3, b part is 4x plus 7, c part is 8x cube plus 2, d part is just x, e part is, or let us say x plus root x, and e part is 4x square plus under root of 3 x plus 5, and lastly let us say x square plus 1 by x cube plus x plus 6. Okay, so all these are the questions, or the all will be called as an algebraic expressions, but not all the expression will be called as polynomials. So only the deciding factor is that the exponent of the variable must be whole number of each and every term. Okay, so if you consider the first one, here the exponent is 2, which is a positive, here exponent is 1, and what about this? Okay, here you can't say that there is an exponent, you can't see directly there is an exponent, but yes, the variable is hidden like this, that it is written as x raised to power 0, meaning it was just written as 3, meaning is 3 is multiplied by 1, and that 1 is written as x raised to power 0, right? So here also all the 3 terms contains variables, right? And the last term which has the variable x whose exponent is 0. Okay, so the exponent of each variable is a whole number or a integer, or it can be 0, so this is a polynomial. Similarly, in the second part, it is 4x plus 7, again here it is x raised to power 0, so it is again a polynomial because here the exponent of x is 1. Similarly, for c part, here the exponent is 3, here 2, so this is again a polynomial function. In the d part, here the exponent is 1, and if I rewrite this as x raised to power 1 plus x raised to power half, because the thirds are written with the fraction powers. So x raised to power half is square root of x. This is positive, but this is a fraction, this is not an integer, right? And if you find a single term, not all the terms, but only a single term is sufficient to find out whether the polynomial is not a function. Okay, so here we have find out a single term where the exponent is not an integer, so the whole expression cannot be called as a polynomial function, right? So this is in the e part. Here the exponent of the variable is 2. Here the exponent is 2. Here the exponent of variable is 1, though this is root 3. So do not get confused with d and e part. In the d part, x means the root was in x was inside the root, but here the x is outside the root. So it is just a constant root 3, right? We are only interested in the exponent of the variables. This is very important, not the exponent of constant. So here the variable's power is again 1 and this is constant. So this is also is a polynomial. And lastly, if you can see here, the exponent is 2, so it is satisfying the property, but here it is x raised to 1 upon x raised to the power q. So if I rewrite this as x square plus x raised to the power minus 3 plus x plus 6. Now if you consider here, this minus 3 is not a positive integer, so the whole function, whole expression is not a polynomial function. Okay, so this is how you will determine whether any expression is a polynomial function or not. Okay, so and also I was about to say yes, and these a0, a1 and a2, these are the coefficients of the variable x, which are just the constants. Okay, these constants can be negative, positive, fraction, or they can be surds also, right? That's it. So any expression of this type will be called as a polynomial function. Now next is the types of polynomial functions. Okay, so first part is constant polynomial, or I would say just a constant function. So as the name is suggesting, it is just a constant function. So any function of the type y is equal to fx is equal to c, where c is a constant, just like 1, 2, 3 or minus 1 or minus half, any constant number, right? So where c is a constant, so it is just a constant function. If you look at the graph of this constant function, it will look, this is your x, y, it will look like this if c is positive and this y-intercept is c. So as you can see in the graph, as the name is suggesting, the value of this function remains constant. So this is a constant function that it will not change its value from c, though the value of x is increasing, but it is just c, so y value is just c, simple, right? B part is next category of polynomial function is the linear function. Linear function. So what is a linear function? So you must have studied the equation of a straight line. So that straight line equation falls under the category of a linear function, right? So any expression of the type y is equal to fx is equal to let us say ax plus b, right? So we are remember, we are categorizing the types of polynomial function only on the basis of the degree of the variable. So we started with degree 0, okay, where the constant was there and there was no x, but there was x written like this, x raised to the power 0. So we are categorizing. You can also write in the heading depending upon the degree of polynomial. Okay, so we have degree of the polynomial, meaning is that whatever is the highest exponent of the variable in the whole expression, that will be called as the degree of the polynomial. Okay, so if you look at the previous questions, so here the highest power of the variable was 2, so we say this is the degree 2 polynomial, right? Similarly, in this case, here the degree is 1, so this is the degree 1 polynomial, which is the linear polynomial, which we were doing just now. Here the highest exponent is 3, so this is a cubic polynomial. Okay, its degree is 3, right? So this was not a polynomial. Here the degree, highest degree of again the variable was 2, so this was a degree 2 polynomial and so on. Okay, so we are categorizing the types of polynomial on the basis of degree of the variable or the polynomial, right? So we had started with the degree 0, which is the constant function. Then comes the degree 1 function, which is the linear function. So as you can see here, the power of x is just 1. Okay, so this is a linear polynomial of the function ax plus b type. So there are certain x terms and there is some constant. It is not necessary that constant should be there, but the power of x should always be 1. It cannot be greater than 2. Greater than 1, sorry. Okay, so if you look at the graph of this function, so it will be just a straight line. So again, this is your x-axis, this is your y-axis, so it will be let us say like this, if you consider the slope and all to be positive. Okay, now since we are dealing with linear function and I have spoken something some term which is the slope, so let us understand the slope also, which you already have done this in your previous classes, that the slope or the gradient of linear function. Okay, so if let us say, because we have studied this in terms of y equal to mx plus c, which is the linear form of, or which is the slope and y-intercept form of an equation. So y equal to mx plus c, right? This equation you have learned, so this falls under the category of a linear function, right? Whose value, the value of m, this is the gradient or the slope of the line. This is the gradient, and this c represents the y-intercept. Okay, so if you locate this c on the graph, so this distance is c and this coordinate is 0, c. Where the straight line is intersecting the y-axis, this is called the y-intercept. Okay, and gradient of a linear function, so m, value of m is a gradient. And what is the meaning of gradient? So if you look closely at this figure, let us say this is your straight line y equal to mx plus c, and it is making an angle theta with the positive x-axis. Okay, this angle is theta, which is making, which this line is making with the positive x-axis. So if you take the tan of this theta, tangent theta, right, this is your gradient or slope. Okay, so gradient is not the theta, in fact it is the tangent of that theta, tan theta, and there is no need to explain what you mean by sine, cosine, tan. Okay, so this was what is called as the linear function. Then let us increase the degree from 1 to 2. If we increase from 1 to 2, we arrive at the third part, which is the quadratic polynomial, whose degree is 2. Okay, so any function, any expression, any polynomial expression of the type y is equal to ax square plus bx plus c, where a should not be equal to 0, right? This a should not be equal to 0, and wherever wherever a quadratic polynomial function is written, and it is incomplete if it is not saying that what about a. So this, mentioning this a not equal to 0 is very, very important if you are defining a quadratic polynomial. Okay, because if you are not defining this a is not equal to 0, that means there can be certain chances where a can be equal to 0, and if a is 0, so this won't be called as a quadratic function, that will be a linear function. So since we are categorizing just quadratic, so this a should not be equal to 0, right? And highest degree of this function then will be 2, then only it will call a quadratic. Okay, so this is your quadratic polynomial or a function, and there can be various graph, not various, there will be 4 different types of graph of this. 4, I would say that there will be 2 only. You can subcategorize those 2, but basic graph is only 2, right? Which is your upwards and downwards parabola, right? So I would say that graph of a quadratic polynomial or function will be a parabola, okay? So it will be a U-shaped curve or a V-shaped curve depending upon the value of a, okay? So let us see case 1. This is your x-axis, this is your y-axis. So case 1 can be that the graph is, let us say, like this. This is called a U-shaped curve, okay? And in this case, the value of a is positive, right? If the value of a is positive, then we say that it will be a U-shaped curve, right? And the second part is just the opposite of this, that if the value of a is negative, okay, this is your y, this is your x, and if a is negative, so it will be an inverted U-shaped curve, right? This is the case where a is negative. So for example, if a is positive, you can consider one example of the type, let us say 2x square plus 5x minus 2, okay? And if this is negative, then you can say minus 3x square plus 2x minus or plus 1, okay? And I'm not going into this, that whether this will be having complex roots or if roots are possible or not. I have just written in terms of the coefficient. We are only considering or concentrating on the coefficient of x square, whether it is positive or negative, okay? So if a is negative, it will be inverted U. If a is positive, it will be a U-shaped curve, right? Now you can shift this quadratic curve either upwards or towards right, or downwards or towards left, right? Then again you will get 4 more different types of curve, but that is not the thing, right? So this is quadratic. And lastly, you can increase the degree from 2 to 3, 3 to 4, 4 to 5, and just for the namesake, at the last, not the last, but the fourth category is the cubic polynomial with the degree 3. With the degree 3, so any cubic polynomial of the type y is equal to fx equal to ax cube plus bx square plus cx plus d, where a should not be equal to 0, will be a cubic polynomial, right? And yes, since we are defining a not equal to 0 in quadratic, in cubic, then this should also be not equal to 0 in linear also, okay? That a should not be equal to 0, right? And there might be some confusion that if a is not equal to 0, means if a is 0, then this will vanish and you will get just y equal to b. Y equal to b meaning any constant function. So can a constant function be called as a linear function? I leave it that to you, okay? Just pause the video and think, right? And write in the comment section what will be your answer if you have been given a function ax plus b type, and let us say a is 0, or in simple terms, write in the comment section whether a constant function can be called as a linear one, because it looks like a straight line. Graph of this is a straight line, no doubt, okay? So cubic polynomial we were doing, and the graph of this will depend upon, again, the value of a. So if a is positive, right, so it will be like this. It will cross at least once, any cubic polynomial will cross at least once the x-axis. If you are going If you're moving from minus infinity below the x-axis, so it will cross like this, and depending upon the roots of this cubic polynomial, it will intersect the x-axis again. Okay, this will be possible if a is less than, not less than, if a is greater than 0 and it has 3 roots, because it is intersecting at 3 points, right? And in the second one, what can be the other possibility? Same, we are saying that a is 0, a is greater than 0, right? So it is intersecting at once here, but it is not coming back downwards and crossing the x-axis again. So it is going like this. So in this case, it is a greater than 0, but it has only one root. Okay. Similarly, if a is negative, then the graph will start from upwards and it will decrease like this, and depending upon the roots, it will cross the x-axis multiple times, right? So this was cubic, and likewise you can increase the degree, you will get the different types of curves, right? But we will deal with only the quadratic polynomial. Sometimes we can deal with cubic also, but our main focus now will be a quadratic polynomial. Right, so quadratic polynomial, as we have just learned, is of the type ax square plus bx plus c, where a should not be equal to 0, right? And in this quadratic polynomial graph we have already done, so we will talk about the roots. Roots in the sense that what are the values of x that will satisfy the equation ax square plus bx plus c equal to 0. What are the roots, what are the values of x that will satisfy this equation? Okay, what are the values of x where the value of the polynomial is 0? Okay, those in polynomial terms are called the zeros of a polynomial, where the value of the function, value of the expression is 0, right? So in equation terms, we call those zeros as the roots. Okay, so wherever the graphically, if we have to represent this, understand the meaning of this, graphically wherever the graph is intersecting the x-axis. Why x-axis? Because the equation of x-axis is y equal to 0. So basically we are solving two simultaneous curves, right? One curve is our quadratic curve, which is in the LHS, and another curve is y equal to 0. Right? Remember how to solve the simultaneous equation as far as linear equations are concerned, right? So simultaneously solving the linear equation graphically means you are intersecting or finding out the point of intersection, right? This time we have the curves, right? So we have a quadratic curve and then we have a straight line. We are finding out the intersection of the parabola with the x-axis, and equation of x-axis is y equal to 0, right? So we can relate this graphically as basically we are finding out the intersection between y equal to 0 and the quadratic curve. Okay, so these are the roots of the quadratic polynomial. These roots can be distinct in this case and real, right? Real in the sense that it will definitely cross the x-axis. You will find distinct roots for this. Okay, and this, so case 1 can be that if roots are real and distinct in the sense that it will go like this, intersect at one point, and again it will come back and intersect at that point. Okay, the other case is also possible if it is going upwards and coming back. Okay, so we are not dealing with the sign of a. You can take whether the sign is a, sign of a is positive or negative. We are not dealing with this. We are just interested in the roots. Okay, so graph can be U-shape or an inverted U-shape. It doesn't matter as far as learning the concept is concerned. So if roots are real and distinct, graphically meaning it is intersecting the x-axis at two distinct points. right? So if this is the case, so we have a quadratic formula in order to solve. Okay, we will deal later on with that. So, and then the case 2, that if case 2 can be that if roots are real, means roots exist, but they are not distinct, they are equal. So if roots are equal, how the graph will look like? So equal roots will be of the type that the graph will intersect the x-axis, not intersect, but it will touch the x-axis at a single point. Okay, meaning the x-axis will be the tangent to the curve. In that case, this indicates the roots are equal, right? So basically what we have done is, in the earlier case 1, though these two roots, we have bring these two roots together and they have become equal. Okay, moving this root to this root to this. So basically we have brought these two roots together at a single point. Okay, so roots are equal, meaning that some straight line is becoming tangent to the curve, right? And case 3, case 3 is roots are, or roots, just a second, roots doesn't exist. Real roots doesn't exist. Okay, that would be more preferred. Or simply you can say that roots are not real, they are complex. Okay, and graphically meaning of this is the curve is not intersecting the x-axis at all. Okay, so it is hanging in the air like this. Okay, it is not intersecting at the x-axis. It may have a y-intercept. Okay, so let us take one example quickly, that what kind of a function will be like this. So since I know, okay, we are not finding out for now. In the next slide we will see how to find out the roots, but let us take one example. Okay, let me introduce you the formula for finding out the roots, right? There will be various methods of finding out the roots. I think you have already known. Okay, so which is called the quadratic formula. There are 2 or 3 ways to find out the roots. One is using the quadratic formula. Okay, which is that if function is of the type ax square plus bx plus c equal to 0, a is not equal to 0. In this quadratic equation, the roots x1 or x2, they are given by minus b plus minus b square minus 4ac square root over 2a. Okay, this is your quadratic formula. Right? So for example, solve x square minus 4x plus 3, okay, equal to 0, solve. So here we can see that a value is 1, the coefficient of x square, which is a is 1, value of b is minus 4, which is a coefficient of x, so coefficient of x is minus 4, with sign you need to take this, and value of c is 3. So using quadratic formula, x1 comma x2, why I am saying x1 comma x2, because there will be 2 roots, there can be 2 roots depending upon whether the roots exist or not. And if roots exist, real roots exist, so one root will be minus b plus and second root will be minus b minus. Okay, so this is a combined formula, only difference between 2 roots is of this plus and minus sign, right? That's why I have written in a single formula x1 comma x2, right? So minus b is minus of minus 4 is 4 plus minus b square. So minus 4 square is 16 minus 4 into a is 1 and c is 3 square root divided by 2a, meaning 2 into 1. So this is 4 plus minus 16 minus 12 is 4, square root of 4 is 2 divided by 2. So one root will be 6 by 2 and second root will be 2 by 2, which is 3 comma 1. This is called the quadratic formula in order to solve, which is used to solve a quadratic equation. Okay, so graphical meaning of this is that it will intersect the x-axis at point 1 comma 3, right? And as you can see that a value is positive, so it will be a u-shaped curve. Curve will be like this. Okay, and as you can see here that value of c, which is the constant here, is 3. It indicates the y-intercept. So this value is 3. So we have a coordinate at y-axis which is 0 comma 3. This value is 1 comma 0, the first root, and second root is 3. So this is 3 comma 0. This is how you can sketch any curve if you know the root of the curve and the equation of a curve also, right? Okay, so here the roots are real and distinct. Second example of equal roots can be, let us say example number 2, x square minus 4x plus 4. Rearranging these, you can have x minus 2 whole square equal to 0. So here you will get x as just 2 or 2 comma 2. So roots are equal. Okay, for equal roots, it will touch the x-axis at point 2. Right, so this is called the factorization method. This is also, I think, you know, and if you do not know the factorization method, write in the comment section. I will cover later on in some other video. Okay, all right, and one more fact I need to give to you as far as linear function is concerned, which is the relation between two perpendicular lines. So if two lines are perpendicular like this, one line is like this and second line is perpendicular to this, okay, and this angle is 90 degrees. Slope of line 1 is m1 and slope of line 2 is m2. So we have a relation, slope in the sense a gradient. So we have a relation that if two lines are perpendicular, so m1, m2 is minus 1. This you need to remember. If two lines are perpendicular, right? And of course, if two straight lines are parallel, the gradients of two lines will be equal, right? Okay. Now let us solve some questions based on the straight line. One more note you should note down. I am remembering that. Not note, but a concept which is called the completing the square. Let us complete that also. So write down the completing the square. Completing the square in the sense is I am just dealing with the algebraic aspect of this, although there is a geometric aspect of completing the square also. Why I am saying this completing the square? So if I am using the term square, so there must be some geometry involved, and of course it is. Right? Okay, just like a plus b whole square. The proof of a plus b whole square is a square plus b square plus 2ab. What is the geometric proof? Okay, so there are certain squares, rectangles involved. Similarly, completing the square also involves some kind of rearrangement of figures. So we are not going into this. We are just dealing with the algebraic aspect of this topic. So let us say we have a quadratic expression which is, let us take x square minus 8x plus 7. Let us take this, right? And you need to write this quadratic expression in completing the square form. So what this completing the square form does is that in the step 1, what you do is you take out or you make the coefficient of x square as 1. Here the coefficient of x square is already as 1, so no need to take any common factor. Okay, so we directly go to the next step. Next step is focusing on x square and minus 8x. We have to write this as x square. If we compare this x square minus 8x, right, and we have to use something x minus a whole square. So basic theme of this completing the square is you have to write this quadratic expression in this form and some constant c. Okay, this is the completing the square form. So we have to open this x square plus a square minus 2x, right? If we open this up as x square minus 2ax plus a square and this plus c, right? So we need to get some x terms here. We have got some x term here and we have x square also. So here also we have x square and there is an x term. So if we compare this with this, okay, I will get the value of a, right? Meaning is that if I do x square minus, not x square, I can write this x square minus 8x as x minus 8 by 2. Okay, 8 by 2 is 4. If I write this as x minus 2, 4 whole square. The benefit of this will be that if I open up this, it will be x square minus 8x. Okay, so till these two terms I have get the terms as x minus 4 whole square, but there will be some extra term also in this x minus 4 whole square, which will be a square or 16 in this case, right? So plus 7 I will write as it is, and whatever is the extra term here, that I will subtract. So minus 16. So minus 16, right? So x minus 4 whole square plus 7 minus 16. This is just for your explanation, right? So this is x minus 4 whole square. Simplifying this is minus 9. So this is how I will write any quadratic expression as completing the square form or of the type x minus a whole square plus some constant. Right? Benefit of this is that if we have to solve this equation, how we will solve this? First, we have converted this into completing the square and now put it equal to 0. It is very simple now to solve this, that it will be x minus 4 whole square equal to 9, transferring 9 to RHS, taking the square root. So x minus 4 will be either plus 3 or minus 3, because removing the square or taking the square root on both the side will give you plus minus, right? So one value will be 4 plus 3, which is 7, and second will be 4 minus 3 is 1. So these are the roots, which is 1, 7. Right? So again, let us take another example to understand the completing the square. Now I am taking any random, okay, expression. Let us take 2x square minus 9x plus 11. Okay, just any random one. I don't know whether I will get beautiful numbers or integer numbers, okay, but nevertheless. So first task was to take out the common factor, not common factor, making the coefficient of x square as 1. Okay, so if I make coefficient of x square as 1, so this is 2, this is x square minus 9 by 2x plus 11 over 2. Okay, there is no harm in doing this. Now I need to focus on these two terms. Okay, and what another term I need to focus, I need to apply, since it is c, what you need to do is there will be two formulas that will be used, either x plus a whole square or x minus a whole square, right? The only difference between these two formulas is of the coefficient of x. Okay, one will be plus 2ax plus a square and second will be minus 2ax and plus a square. So only difference lies in this plus and this minus, which is the coefficient of x, whether it is plus or minus. So if here the coefficient of x is of minus, that means you will use x minus a formula. You need to convert this into x minus a whole square plus something type, right? So here, first thing is this. Second is that if I open up like this and I need to write from here till here to here, meaning I need to compare the coefficient of x, which is 2a, with this, right? So this 9 by 2, this 9 by 2 basically is representing 2a in the formula. Okay, what I am doing is that I have to write this as x minus a whole square. This you will agree with me, right? I need to write this x minus a whole square type. So what will be the value of a? So if I open this up, x minus a whole square, it will be x square minus 2ax. I have x square here and I will get minus 2ax, right? So minus 2a value is minus 9 by 2, or symbol 9 by 2 is 2 by a. So from here I will get value of a as 9 by 4, right? So directly writing this as 2 is outside, this is x minus 9 by 4 whole square, right? Plus 11 by 2 I will write as it is. Whatever is the constant term here left after taking out the constant or the coefficient of 2, leave this constant as it is, which is 11 by 2, and think of the extra term that you will get after opening this x minus a whole square, because this is not in the original expression. You need to subtract that one. That extra term you get only after you are applying x minus a whole square. So that extra term is this a square. That needs to be subtracted. So what is a square? 81 by 16. That needs to be subtracted. Okay. So again, simplifying this is x minus 9 by 4 whole square, plus this is 88 minus 81 is 7 by 16. Multiplying this by 2, meaning multiply this 2, this is 2, x minus 9 by 4 whole square plus 7 by 8. So this is your whole complete in the square form. Now what is the use of this? This is very, very important. Pay attention. This x minus 9 by 4, this 9 by 4 and this 7 by 8, these are the vertex of parabola. These are the vertex of parabola. Why I am saying parabola? Because it is a U-shaped curve. It is a parabola because it is a quadratic function, right? So if we have a parabola like this, so vertex meaning is this lowest point. You can also write this as the lowest point if it is U-shaped. Okay, if it is inverted U like this, then it will be the highest point, right? So it is called the vertex. So this coordinate, the x coordinate will be 9 by 4 and y coordinate will be 7 by 8, right? Had it been plus 9 by 4, okay, let us do one exercise example. A x plus 2 whole square plus 4, right? So what are the vertex coordinate for this parabola? You will say that my parabola will be like this. Why it will be U-shaped? Because the coefficient of x here is plus. So if I open up this bracket, I will get positive x square. So it will be a U-shaped curve, right? One thing. Second is, since it is plus 2, so now the vertex coordinates will be minus 2. And y will be plus, so it will be plus only. Right? So vertex coordinate are minus 2, 4. B part. X plus 3 whole square minus 6. In this case, again, it will be a U-shaped curve. X coordinate will be minus 3. If it is plus, it will be minus. but y coordinate will be as it is. Mean whatever is the sign of y coordinate, you do not have to need to change the sign of the coordinate. So minus 6 will remain as minus 6 only. So these are the vertex coordinate. X minus, let us say 1 whole square plus 6. So in this case, again U-shaped curve. This time the x coordinates are 1 comma plus 6 and so on. Okay, and the vertex coordinates are the minimum point for a U-shaped curve, and those will be the maximum point for a U-shape, for a inverted U-shape curve. Okay, had it been a negative number like this, then graph will be like this. In that case, those coordinates will become the maximum. You have to readjust these. Okay, it will not reflect just by minus, it will become like this. Definitely y coordinate will change. Okay, whatever is the case. All right, so based on this, completing the square we have done, let us do one question which says that complete the square and find the minimum value of this one. Right, so I think that is now a piece of cake. Solution, writing this as x minus 2 whole square. Okay, why I have done this directly? Okay, let us solve this step by step. Since coefficient of x square is already plus 1, no need to take any constant. Now here the x coefficient is of minus, so I have to convert this as x minus a whole square. Okay, if I open this up, x square minus 2ax, I will get plus a square. So minus 2a value is minus 4, meaning 2a value is 4, a value is 2. You can also do this directly. You can obtain the value of a just by looking at the coefficient of x. You just divide this by 2. If it is 4, you get 2. Earlier, you get 11. You were getting 11, no? 9 you were getting. 9 by 2. Okay, so 9 by 2, you half 9 by 2, you will get 9 by 4 and so on. Right, so value of a is 2. So I have x minus 2 whole square plus 9 I will write as it is. Now think of the extra term. If you open this bracket, you will get x square minus 4x is there, plus 9 is there, yes, plus 9 is there, but 1 plus 2 square will be there. So minus 4 you need to do. The extra term need to be subtracted. Remember, this extra term you are getting only by opening this bracket. Right, so this is x minus 2 whole square plus 5. Inverted, not inverted u, it will be a U-shaped curve. Vertex coordinates are 2, 5. Okay, so find the minimum value of the function. Now just remember, if I am talking about the value of the function value is the y coordinate. So minimum value of this curve is not 2. 2 is the x coordinate. But the value of the function is the value of y. So answer is 5 in this case. Okay. So this is about the polynomial function, and more importantly, how to use the quadratic formula, how to use the completeness square, and finding out the minimum or maximum value by finding out the coordinates of vertex. Okay, so that's all for now. See you in the next lesson. Right, we will talk more about the functions. Okay, I hope you enjoyed today's lecture. Write any comment if you want, any positive comment, I would hope. Okay, so thank you and see you soon. Bye.